Okay, thank you very much for coming. So today we'll be talking about the firewall Mangle here. Firewall Mangle with PBR. PBR means policy-based routing. And then our case study here is we are steering outbound traffic based on destination address list. So previously we were also steering outbound traffic based on the incoming interface. So in the previous webinar, we talk about we have internet server in our network, and then that server will be accessed by different different ISP from. So we have more than one inbound traffic. So at the moment, we don't have that LAN, we don't have the server. So we are just focusing on the outbound traffic. All right. So our agenda will be, okay, it's quite long, it's quite intense. We do review, talk about firewall Mangle, PBR, address list, and then we do the steering. Okay, so for those who are new to GLC, we are Garda Lintas Cakrawala. We are based in Bandung. We do MikroTik, Linux, and programming stuff. We also develop our own Radius Manager, and we do training as well. This is me. My name is Ahmad Mardiansyah. I'm based in Bandung too. A Linux user, MikroTik user, many users, programming developer, a programmer, developer, and a user of programming stuff like SQL, PostgreSQL, what else? PHP and Python. Okay, so if you have LinkedIn account, we can connect here. Okay, this is my LinkedIn. Okay, you can just Google my name, and then hopefully you can see it there. Is it recorded? Yeah. Okay, so this is our past experience. So mostly we do MikroTik stuff related to networking and other stuff in Indonesia and overseas. And thank you very much for coming. At least you can share from where you are from. And the prerequisite for this presentation is at least you know this area. At least you know what the TCP/IP is. Of course, the MikroTik, because we are talking about MikroTik product here. At least you know how to operate MikroTik router OS. Also, here is the firewall, address list, mangles, and etc. etc. All right, so let's continue with the review. So we know O7 OC layer. So from one layer 1 to layer 7, actually is a grouping of functions. So each layer has its own function and has its own mechanism for data exchange. The way we exchange data by using encapsulation process. So this is your data, and then before it's sent to the medium, it needs to the data needs to be added with additional information. So if you check the encapsulation process, so this is the data that you send on you type on your WhatsApp, and then this is what happened in layer 4, okay, and this is the layer 3, okay, this long, and then this is layer 2 up to layer 2. So you have a trailer and then a header here. This is a header if you use Ethernet. This is header looks like layer 2 header looks like if you are using Wi-Fi, okay, and then if you combine Wi-Fi and MPLS, this is how it looks like. So this is what you send. This is what you type here. Okay, this long, and this is what you send. Okay, so a lot of information. Right, so we need to know the difference between router and routing. Okay, router is the device, routing is the process. And then the way we develop our own network is by set up a physical topology. This device connect to that device. And all devices in the network needs to be drawn or depicted in the diagram. Okay, so we call it the topology. Okay, so how the network is shaped, the shape of the network. Okay, so after we form the physical and then we develop the logical. So here we don't use the layer 2 anymore. We are focusing on layer 3. Okay, so which is the IP address. This is what happened when the routing process happens. So here is the how the routing table looks like. Okay, so we have a destination and then we have a gateway here. And when the packet come, and then people will check the routing table whether its entry match or not. Okay, so this is the destination here. Okay, and then we convert it into the binary, and then we check one by one. So is it match, 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 match? If not, and then we use the last one here, which is the default gateway. Okay, so that's how routing table works, and this is where the routing table lookup happens at the routing decision. Okay, so packets coming from here and then going out there. So it's coming here. Okay, and then we have a routing decision which decide whether it's input or forward. Okay, and then after that we go to post routing and then packet coming out on output interface. So it is possible that input interface and output interface are the same interface. Yes, it's possible. This is how routing works and administrative distance. Yes. So yeah, this is how a routing table looks like. So, okay, if you are in a junction, okay, you can say this is the gateway, and then here's your destination, and then here's the distance. Yeah, so if you go, and then this will be this one looks like a table, and then we will convert the tables into something like this. Okay, so you have a destination, gateway, and then here's the distance. And then same table also happens in the real routers. Okay, so same tables like this. Okay, what you have a destination, right? You have a gateway, right? And then you also have distance. Yeah. So lowers the distance, wins. And then on each protocol has its own distance. Yeah. So if we use a routing protocol here, okay. So if it is static route, usually it's 1. Okay. If it is OSPF, is 110. RIP, where is RIP? Okay, it's 120. If it is internal BGP, is 200. External BGP here is 20. So yeah, so internal BGP is 200 times higher than 10 times higher than the external BGP. Oops. Yeah, so this is static routing. So you need to log into each router and then modify the routing tables. Yeah, 5 is okay. 5 router is okay, but 15 router maybe is still okay. If 50 router, you need to use dynamic routing protocol. Okay. Yeah. So yeah, static routing. Yeah, it's good. You have a full control. Yes, but you cannot scale. Yeah, if you want to scale and then use dynamic routing. Okay, by implementing the routing protocol, either RIP, OSPF, or BGP. Okay, so and then we need to know that with routing protocol or routing, we have a routing metric is a value used by router to making decision. Okay, so it depends. So for example, OSPF here, OSPF, okay, this one. So these are the value. Yeah, so accumulated cost on each interface from source to destination. And then here's the RIP. This is OSPF based on cost, so they are similar. And then yeah, GRP and BGP. So you need to know that we have asymmetric routing. So outbound and inbound, they can be in the different path. Okay, as you can see here. Okay, outbound is, oops. So outbound is this way. Okay, this path, but inbound is to here. So we are focusing on this house, right? So this is our outbound. This is our inbound. Okay now, yeah. Yeah, so let's talk about the firewall. So firewall is a feature for controlling network access. So which is filter, oops, or modify network header or marking packets, which is Mangle. So it has two parts, matches and action, executed sequentially, and then yeah, NetAdmin must understand application characteristic in order to build the matches. Okay, for example, the browsing means traffic with TCP port 80 or I think 443. Okay, I will update the slides. Yeah, in the next before we upload it to SlideShare. We usually put SlideShare there on for slide. Okay, so this is how firewall works. Okay, so if you open IP firewalls and then you have lots of tabs. Actually, the first three tab is for matchers. Okay, so this is matchers. So you define matchers, and then the last part here is the action here. Okay, so this action similar to this one. Yeah. So both matcher and action equals to firewall rules. So and then the rule is executed sequentially. Okay. Yeah, this is the where the packet is processed. So same thing. So if you take a look, so packets coming here on input interface, go to pre-routing and then routing decision, either forward or input. If it is input, and then we will process it, and then going back, return back, and then both of them will go to post routing and then output. So if you zoom this one, we get this one. If we zoom this one, we get this. If we zoom output, and then this is what we got. Okay. So inside on each, we call it chain. So we have 5 chains here. 1, 2, 3, 4, 5. Okay. So 5 chain. Oops. Yeah. So 5 chains. Okay. Yeah. So as I said, in the normal firewall, we have three functions, either filter, NAT, or Mangle, and then you need to know that on firewall we have five chain. Yeah. So if you want, but not all tables are available on chains. So filter here is only available on input, available on forward, and then available on output. Okay, and then so on and so forth. So if it is Mangle, and then it will be available on every how do I say, every chain. Okay. Okay. So yeah, we need to know the difference between input and forward. if the packet is just passing through the router. For example, this is your router, and then you go to internet. So this is your internet, and then this is your router. Okay, and then so for this case, it is the forward. Okay, because this is your computer. Oops. Yeah, this is your computer. You want to go to internet. So your final destination, not the router itself, but the internet. So it means that you'll be using forward. Okay, so that's the difference between input and forward. And then I see many people do not understand how it works. Okay, so yeah, it was the firewall, and then other firewall rules feature is called connection. So connection is a relationship between two hosts. Yeah, and then the relationship can be identified, okay, by a pair of IP address. For example, this one here, and source and destination. Yeah. So this is one connection. Okay. So what do we see here? Looks like it's a SIP. Yeah. So we can see this is 50, 60. Okay. Others are here. Okay. And then this is ICMP. Yeah. So as you can see, yeah, not all connections involve IP port like this. Okay. Okay. Next feature is called address list. Yeah. So this is the address list. Okay. And then you select your address list here as well. Okay. So this one. And then here's the results. Okay. So here's the table. So the way you put the address list is you can type directly the IP address, or you can type www.url. Okay. So if you do it like that, so if you type facebook.com here, it will create the URL. Okay. So the host name, www.facebook.com, and MikroTik will automatically translate it to IP address. So the important thing here is, as you can see, firewall address list contains address list. Okay. contain IP address. Sorry, it's a feature for grouping IP address and referred name by name. So for example, this is the name. Okay. And then yeah, you input the IP address manually. Okay. So this one here, or input domain name like this. Okay. Now let's talk about Mangle. So Mangle has is available on many chains. All of them is available, and then here are the things that you can do for Mangle. Yeah. So usually we can do like fast track connection, jump connection, mark packet, math routing, pass through. Those are the action. Yeah. Okay. As you can see, we have several action here. Okay. So first is mark connection, or mark packet, or mark routing. So this is the one that will be used by the network admin. Okay, so first is mark packet. So mark packet is for identify packets, of course. Yeah. Yes. So if you want to mark packet to or from Google, then you need to distinguish them. Okay, so either with the new packet mark packet to Google DNS, or packet from Google DNS, this one. Okay, so that's the mark packet. And the next is mark connection. So as in the name suggests, the name is mark connection. right? To identify connection. As simple as that. And because it's identify connection and then connection has two hosts, so that means mark connections also equals to two-way. Okay, so both are inbound or outbound. Okay, so connection between them will be monitored. Okay, and then if we put mark, we put mark on the connection. Yeah, if you have this one here, if you already have the connection, mark connection, for example, connection Google DNS. Oops, oh, Google DNS here, and then this is the results. Okay, so next is PBR, policy-based routing. So in your scenario, this is a single gateway scenario. You have a default route via ISP 1. Okay, so because you only have one ISP, what you can do is send data through the ISP, and then ISP will forward to other ISP. So yeah, as you can see here, main outbound and main inbound are via ISP 1. Okay, so this is very, very simple topology. And next is a multiple gateway. So here you're not only use one ISP, okay, but two, ISP 1, ISP 2. So because ISP 1 is the default, okay, so we talk about default route. What is default route? Is 0000. That's the default. Okay, so yeah, no inbound access, so there is no server here, no server. So we will not expect anybody to access the server IP address. Okay, so we can just focusing on outbound traffic based on the target address list. So it means that we will have the address list, okay, target address list, and then here's the plan to forward the packet through either 1 or either 2. Yeah, and then we have yeah, so the thing is what we want is we already have a list of IP address. Yeah, we have discussed it previously, right? So this IP addresses, okay, so it's a group of IP address. So outbound will be here. Second is this one. Yeah. So with our setting like this, with normal setting, so we only refer to the outbound default outbound. So in this case, even though we have two, and then yeah, as a default, they just send data through one ISP. Okay. Yeah. So with the PBR, we can use things like that. Okay. So this list, so we have a list here. First list goes here. Second list here goes this one. So that's the purpose of PBR. So it's a specific technique to route traffic based on specific rules. So you can use IP rules, routing rules, or or we can use others. We can use Mangle like this. So our strategy is we create the target address list first. Yeah, 1 or 2. Okay, so not or n. So target here. This is next target. So inside we have IP addresses. Okay, and then we do mark routing. Okay, this one goes this one. This one goes this one. So what are the steps? Well, it's not that hard. So first, is you need to create a custom a table. Okay, so via ISP1, via ISP2. Okay, so this is ISP1, this is ISP2. Okay, and then you create IP route add. Okay, so this is the default. Here's the gateway, check gateway, and then this is routing table. Okay, so routing table, this one is this one. Okay, so first is we do in the routing, IP routes. Okay, next is address list. We put address list. Yeah, so here are the examples. Okay, and then here's the name. Yeah, and then after that, we set up the MARC routing. Okay, so this is our LAN. You want to go to the internet, and then so on the internet we do this thing. Okay, so input interface is ether4, target is address list 1, and then routing MARC through via ISP1. Okay, so same thing here. This is 2. Okay, via ISP2, and done. Yeah, so if you want to check, it's easy. From here, you do trace route to this one, for example, like what I'm using here. Maybe orange, yeah. So you do trace route here, 8888. Oops. Okay, and then first goes to this one, 30.1 here. Oh, sorry, not that one. So actually there is a modem here, right? Then from here go to up. Then we can see this is 0111 is the default gateway of this one here. Okay. Yeah, so I think that's all. Yeah. If you have questions, and then please write them in the group chat, or send us email or WhatsApp. Okay. Yeah, if you're interested more, just contact us if you want to do training. And yeah, this is end of slides. Yeah, it's quite short, but actually it's a lot. It's a lot. Okay. So your feedback is here. Oops. Okay, schedule will be on our website. We have Facebook, we have slide also. So the slide will be here. This is our Discord, and then here's the recording. Right, so I think that's all for today. Thank you very much for coming. And then I'll see you in the next webinar. Thank you and goodbye.